Welcome to Creata classes. In this lecture, we will cover the distance formula in the coordinate system. In this lecture, we will try to learn how to calculate the distance between any two given coordinate in the coordinate system. Let's begin with the lecture. In this lecture, we will see the formula through which we can calculate the distance between any two given coordinates. Before moving to the formula, let's try to calculate the distance between any two given coordinate. Say in our first case, we will take the two coordinate, say the point A as 3, 2 and the point B as 6, 5. We will try to calculate the distance between point A and point B. Here the coordinate of point A is 3, 2, means its x coordinate is 3 and y coordinate is 2. These two lines are perpendicular to x-axis and y-axis. Similarly, the coordinate of B is 6, 5. Here the x coordinate of point B is 6 and the y coordinate of the point B is 5. Okay, these two lines are perpendicular to x-axis and y-axis. Okay, I am not going into the detail of how to plot these points in the coordinate system that we have already covered in the previous lecture. So with the help of the previous lecture, we are able to plot these 2 points in the coordinate system. Moving further, the fundamental that we will use to calculate the distance between any two given point is the Pythagoras theorem. You all know what is the Pythagoras theorem. In a given right angle triangle, the hypotenuse square is equal to sum of square of two legs of the triangle. This is the Pythagoras theorem. Okay, if we have to apply the Pythagoras theorem, then we have to locate the right angle triangle. If you observe, A and B are 2 points and these two lines are perpendicular to x-axis and these two lines are perpendicular to y-axis. Let's extend this line. Okay, we have extended this perpendicular line. Are you able to observe this is a triangle? This line is perpendicular to y-axis and this line is perpendicular to x-axis. Means this angle will be a 90-degree angle. It means this triangle is a right angle triangle. Okay, got it? Being a right angle triangle, we can apply the Pythagoras. Let's mark this point as point O. Here for this triangle ABO, the side AB is the hypotenuse and OB and OA are the two legs of the triangle. If we apply the Pythagoras, we got AB square is equal to OA square plus OB square. Okay, we can apply the Pythagoras in this triangle. Here, if you observe, we have to calculate the length of the side AB. That is, we have to calculate the length of the hypotenuse. Here, with the help of these coordinates, can we calculate the distance of OA and OB? Here, this length is 3 and this complete length is 6. So, can we calculate OA as 6 minus 3? That will be equal to 3 unit. Similarly, OB will be equal to 5 minus 2. That will be equal to 3. So, for this triangle, we got these two legs as 3 unit. We know the two legs of the triangle. We can calculate the hypotenuse, that is AB. That will be equal to AB square is equal to 3 square plus 3 square. So our side AB will comes out to be root of 9 plus 9, that is root of 18. That is the length of AB or the distance between the point A and B. So we understood that if we have to calculate the distance between any 2 points in the coordinate system, then we can form a right angle triangle and we can apply the Pythagoras to find the distance between the 2 points. This is a strategy or the fundamental that we can use to find the distance between any 2 points. Okay. Let's take one more example. Now we will take the 2 points in 2 different quadrants. Let's take our first point in the first quadrant, that is 4, 3. Here 4 is the x coordinate and 3 is the y coordinate. This is point A. Now in the third quadrant, let's take our point B. The coordinate are -5, -2. Here -5 is the x coordinate and -2 is the y coordinate. Okay, got it. With the help of our first lecture, we can plot these 2 points, that is A and B. Let's join A and B. We have to calculate the distance between A and B, that is the length of side AB. The same fundamental we will use. We will try to locate a right angle triangle, and with the help of this right angle triangle, we will calculate the distance between the 2 points with the help of the Pythagoras theorem. So our first step, we will try to locate a right angle triangle. Here these lines are perpendicular to x-axis and y-axis. Let's extend these two lines. These two perpendicular lines are meeting at this point. Now, are you able to visualize this right angle triangle? Okay, this angle is 90 degree. So this triangle is a right angle triangle. Let's mark this point as point O. Here for this right angle triangle OAB, we have to calculate the distance of the hypotenuse, that is AB. Let's proceed. Here this distance is 3 unit and this distance is 2 unit. So in totality, this complete length will be equal to 3 plus 2, that is 5 unit. So what will be the distance OB? OB will be equal to 4 plus 5. Okay, that will be 9 unit. Okay, any confusion? This is 4 and this is 5. So total it will be 4 plus 5, that is 9 unit. So for this right angle triangle, we got OA as 5 unit and OB as 9 unit. Let's apply the Pythagoras. That will be equal to AB square is equal to OA square plus OB square. Let's put the value. We got the distance AB as root 106. Okay, that is the answer or the distance between the point A and B. Okay, got it? So we understood that if the 2 points are in 2 different quadrants, then also we can use this fundamental, that is to identify a right angle triangle and apply the Pythagoras. One thing that I just want to add is that if in spite of this right angle triangle, if we have taken this right angle triangle also, then also the result will be same. This distance will be equal to 5 and this distance will be equal to 9. So you can identify any right angle triangle in which the hypotenuse is equal to AB, that is the length of the side whose distance we have to calculate. Okay, got it? So again, my advice, just stick with the basic fundamental, the answer will come automatically. Now let's move further. In this case, we will assume the 2 points in the first quadrant as x1, y1 and x2, y2. We have assumed the 2 points. The first point is x1, y1 and the second point is x2, y2. Here x1, y1 means the x coordinate is x1 and the y coordinate is y1. For the time being, we are removing all the numbers. We are just concerned with x1, y1, x2, y2. Similarly, for the point B, this will be x2 and this will be y2. Here we have to calculate the distance AB, that is the distance between the point A and B. The same fundamental we will use. We will locate a right angle triangle and we will apply the Pythagoras theorem. Okay. So as per the fundamental, this is our right angle triangle. These two lines are perpendicular to each other. This angle is a 90 degree angle. So this triangle, that is OAB, is a right angle triangle. Now we will calculate the length of side OA and OB so that we can apply the Pythagoras. Here, if you observe, this is x1 and this length is x2 and we have to calculate OA. Can we say OA is equal to x2 minus x1? Okay, this distance will be equal to x2 minus x1. Similarly, we have to calculate OB. This complete length is y2 and this length is y1. So can we say OB is equal to y2 minus y1? So we got OA is equal to x2 minus x1 and OB is equal to y2 minus y1. And we have to calculate the distance AB. We got 2 legs of the triangle. Let's apply the Pythagoras. So we got AB square is equal to OA square plus OB square. Let's put the value. On putting the value and solving, we got AB is equal to root of x2 minus x1 square plus y2 minus y1 square. This formula is known as the distance formula. If we know any 2 points, that is x1 y1 and x2 y2, we can apply this formula to calculate the distance between these 2 points. Okay, got it? This is very important formula, you should know it. This formula will be also used in the trigonometry to derive the formula of cos a plus b, cos a minus b. So this is very important formula, you should know it. Okay. Moving further, we got the distance formula. Before this distance formula, we have taken two cases in which we have calculated the distance between the 2 points. Those two cases we have solved with the help of Pythagoras theorem without this distance formula. Now we will check whether the distance formula is applicable in those two cases or not. So let's check the applicability of our distance formula. In the first case, we have calculated the distance between our point A and B, that is the coordinate 3, 2 and the coordinate 6, 5 as root of 18. Let's see the applicability of the formula. Here x1, y1 is 3, 2 and x2, y2 is 6, 5. So we got x1 as 3 and y1 as 2 and x2 as 6 and y2 as 5. Let's put the value in our formula, that is distance is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. On putting the value and solving, we got our answer as root of 18. Okay, we got our answer as correct. That is root of 18, the same answer we have also got with the help of the Pythagoras. This shows that this formula is applicable. Now moving further, the actual trick to apply the formula comes when the 2 points are in 2 different quadrants. Or we can say when the one coordinate is having the positive symbol and the second coordinate is having the negative symbol. Let's see what I am talking about. The second case that we have done, where our point A is 4, 3 and our point B is minus 5, minus 2. Let's see whether this formula is applicable or not. Here x1, y1 is 4, 3, that is x1 is equal to 4 and y1 is equal to 3. And x2, y2 is minus 5, minus 2, that is x2 is equal to minus 5 and y2 is equal to minus 2. We got the value of x1, x2, y1 and y2. Let's see whether this formula is applicable or not. Okay, let's put the value. 4 minus minus 5 whole square plus 3 minus minus 2 whole square. On solving, we got our result as root of 106. This result is matching with our previous answer. So we can say this formula is also applicable when the 2 points are in the 2 different quadrants. Okay. Let's move further. One point to be noted here is that if we replace x1 minus x2 with x2 minus x1 and y1 minus y2 with y2 minus y1, anything will change? No, nothing will change. Why? Because both these terms are having the square. Whatever value you will put, if it is in negative, on squaring the term, it will again come to positive. So the formula will remain unchanged. So you can take any of these points as x1 and y1 and the other point as x2 and y2. Okay, got it? Okay students, we have understood what the distance formula is. A small question for you. Try to solve this question by pausing the video. Take your own time. Okay, let's see the answer. Our first question is, we have to find the distance between the two coordinates, that is 2, 3 and 4, 1. Here if we take x1, y1 as 2, 3 and x2, y2 as 4, 1, we can directly apply our distance formula, that is root of x2 minus x1 whole square plus y2 minus y1 whole square. Simply we have to just put the value. On putting the value, we got answer of our first question as 2 root 2. Got it? Hope you have got the same answer. Let's jump to the second question. In this question, we have to find the distance between the coordinate minus 5, 7 and minus 1, 3. Here x1 y1 is minus 5 comma 7 and x2 y2 is minus 1 comma 3. Directly putting the value, on solving we got our answer, that is the distance between these 2 points as 4 root 2. Okay, got it? Very simple one, just to show you the implementation of the formula. Let's move further. We will take some advanced question to show the implementation of this formula in indirect way. Let's see. The question is, check whether 5 comma minus 2, 6 comma 4 and 7 comma minus 2 are the vertices of an isosceles triangle. This question is slightly indirect in nature. The distance formula will be applicable. I will show you how this formula will be applicable. 3 coordinates are given and these 3 coordinates are given as the vertices of a triangle. We have to identify whether this triangle is an isosceles triangle or not. Okay? So the fundamental is the definition of an isosceles triangle. We know isosceles triangle is a triangle which is having two sides as equal to each other. So first of all, with the help of the distance formula, we will try to find the sides of this triangle. Then we will see whether the two sides are matching or not. That is, the triangle is isosceles triangle or not. Okay, so this is the strategy that we will use. Let's find the sides of this triangle. Firstly, let's find the side AB. The coordinate of A is 5 comma minus 2 and the coordinate of B is 6 comma 4. We know x1 y1 and x2 y2. Let's use the distance formula to calculate the distance of AB. On putting the value and solving, we got AB as root of 37. Okay, we have directly applied the distance formula. We got one side of this triangle. Let's move further and try to find the side BC. Here these are the two coordinates. Let's assume B as x1 y1 and C as x2 y2. So we got x1 y1 as 6 comma 4 and x2 y2 as 7 comma minus 2. So we will use our distance formula. On putting the value and solving, we got BC, that is distance between these 2 points, as root of 37. Let's move further and we will try to find the distance AC. Here let's assume x1 y1 as 5 comma minus 2 and x2 y2 as 7 comma minus 2. Okay, we will use our distance formula. Let's put the value. On solving, we got AC as 2 unit. Got it? So we got the three sides of this triangle, that is AB as root of 37, BC as root of 37 and AC as 2 unit. Okay, the two sides, that is AB and BC, are equal to each other. That is, this triangle is an isosceles triangle. Okay, got it? So with the help of the distance formula, we have proved this triangle ABC is an isosceles triangle. Got it? That is the answer of this question. So let's move further to the next question. The question is, find the value of y for which the distance between the point P 2 comma minus 3 and Q 10 comma y is 10 units. Okay, take your time and try to solve this question. Okay, pause this video. So let's approach this question. In this question, 2 points, that is point P and point Q, are given. The coordinate of point P is given as 2 comma minus 3 and coordinate of Q is given as 10 comma y. Here y is missing. We have to calculate the value of y. In this question, the distance between the point P and Q is given as 10 unit. Okay, the distance between the 2 points is given as 10 unit. And we have to find the value of y, that is, we have to locate the coordinate of point Q. So we will use the distance formula, that is, distance between point P and Q will be equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Here let's assume the point P as x1 y1, that is, x1 is equal to 2 and y1 is equal to minus 3. And also assume the point Q as x2 y2. Here x2 is 10 and y2 is y. So let's use the distance formula. Let's put the value. On putting the value and solving, we got the value of y as 3. So we got the coordinate q as 10 comma 3. Here the y coordinate of point q is 3 unit. So that is the answer of this question. Okay, got it? Simple one. Let's move further to the next question. The question is, name the type of quadrilateral formed by joining the point -1 comma -2, 1 comma 0, -1 comma 2 and -3 comma 0. Take your time, pause the video and solve this question. Okay, let's approach this question. The 4 points of the quadrilateral are given. Let's name these 4 points as A, B, C and D. 4 points are given, so we can form a quadrilateral with these 4 points. In this question, we have to name the type of the quadrilateral formed. Okay, we have to tell whether this is a trapezium or a kite or a parallelogram, rectangle, rhombus, square. Means we have to identify what is the type of this quadrilateral. So what approach we will use? We will find the length of the side of this quadrilateral. Okay, then we will decide what is the type of this quadrilateral. So let's approach this question. We know all the 4 coordinates of this quadrilateral. By applying the distance formula, we can calculate the side AB, BC, CD and DA. So let's apply the distance formula and let's find the side AB. Here let's assume A as x1, y1 and B as x2, y2. Let's put the value and let's solve it. We got the side AB as 2 root 2. I am not going into the detail of this formula, what is x2 and what is x1. I am assuming that you have understood the concept, what is x1, y1 and x2, y2 and how to apply this formula. I am just fast forwarding it. Okay, I am assuming you know how to apply the distance formula. So we got AB, that is side of this quadrilateral, as 2 root 2. Okay. Let's move further. Let's try to calculate the side BC. Here let's assume the point B as x1, y1 and the point C as x2, y2. Let's put the value. We got the side BC as 2 root 2. Similarly, we can find the side CD. We got CD as 2 root 2 and also DA, that is the fourth side of this quadrilateral, as 2 root 2. So if you observe, we got all the 4 sides of this quadrilateral is 2 root 2. Can we identify the type of this quadrilateral? The quadrilateral which is having all the 4 sides as equal, what it is? It can be either rhombus or it can be square. We know all the 4 sides of a rhombus are equal as well as all the 4 sides of a square are equal. So it can be either rhombus or it can be either a square. So let's move further and try to identify what exactly this quadrilateral is. So now we will try to find the diagonal of this quadrilateral. Here AC is a diagonal and BD is a diagonal. We know all the 4 coordinates, so we can easily find the diagonal with the help of distance formula. On putting the value, we got AC, that is our first diagonal, as 4 unit. Similarly, we can calculate the BD. On applying the distance formula, we got BD, that is our second diagonal, as 4 unit. So we got AC and BD both equal to 4 unit, that is diagonal of this quadrilateral is equal to each other. So we got all the 4 sides of this quadrilateral as equal. Also both the diagonals are equal to each other, which shows that this quadrilateral is a square. The diagonals of the rhombus are not equal to each other, whereas the diagonals of the square are equal to each other. Okay, so this is the answer of this question. Okay, got it? So I hope you have understood this concept. So that's it for this lecture, that is we have covered the distance formula. Thank you very much for being with Creata classes. Bye for now.